Hi everyone, hope you are doing fine. So today we are going to solve the weekly contest 514 of the lead code. So yeah, let's get started with the first problem. So the first problem is minimum total price after applying discount. So in this problem, we have given a two array. First one is the price and the second one is the discount. So like price of I represent the price of ith item and discount of j represent the discount percentage. So like we have given some rule like we can apply only one discount to any item. So this is, and the second is like an item may also receive no discount. Like in this problem you can see like we have three items but the discount is only two. So we can only apply two discount, like either we can apply to this first two either second third, or something like first and the third. So after applying the discount, we have to return the minimum possible sum of final prices after assigning the discount optimally. So yeah, so to calculate the we can say the discount after applying percentage, the formula is given. So yeah, so let's see how we can solve this problem. So let's take the example from here only. So one thing that immediately come in mind after reading this problem is that like you can take we have given something price like 10, 30 and 21. Let's write it in a decreasing order. So if we write it in a decreasing order, it look like this, and also write discount in a decreasing order. Because like if the value is greater, like if we have something like a 100, if we apply 60% discount on this, it value become 40. But if we have a value of you can say item cost is 40 and apply 60%, we can say 50% discount, then it will come to 20 only. So you can see like let's say this is also 50, so 50% discount. So in this price become 50. So you can see like in this we get decrease cost by 50, but in this case only cost decreases by 20. So you can see like it's always benefit to apply the maximum discount to the maximum price item. So like in this the price maximum is 30 and the maximum discount is 60. So you can apply to this, and similarly now we can apply to this, and after that 21 value is 21 and the discount is 50%, so we can apply 50% to this. So yeah, you can see like if we apply discount we can say 60% to the price 30, it become 12. And if we apply discount of 50% to 21, it become 10.5. And because there is no other discount, this 10 will remain as same. So after adding, it becomes something like 10 plus 10 20 plus 12 32.5. You can see like 32.5, we are getting this answer. Like similarly, like you can see like the code, it's a very easy. We are just sorting sorting this body array and then reversing, and then we are simply checking like if the we are simply applying the price, applying the discount. And if the we can say because the discount array can be less than the price, so like if we reach that point, it mean like now we have to take that whole price. So in that case we are taking the whole price and doing continue, so that we move to the next index of the array. And if that is not the case, then we are simply storing discount is this discount of index in a discount, and then we are using this formula to calculate the discount we get. And after that we are simply applying the price, like that discounted price we are adding it, and iterating to the next index of we can say discount. So yeah, so that it was a pretty easy problem. So yeah, let's move to the second problem. So the second problem is based on a tree. So yeah, so in this problem we are given a parent array of a length n, representing a rooted tree with the nodes labeled from 0 to n minus 1. The tree is rooted at node 0, so parent of 0 become is minus 1, and for each node I greater than equal to 1 and less than equal to n minus 1, parent of I denotes the parent of that node. So you are given an integer array nums of length n, where nums of I denotes the value of node I, and the weight of the node I, like if the node I is at a depth d, let's say this is depth 1, this is depth 2, then the answer, the formula to calculate this answer is this: some like a nums of I value for that node, which that node into height minus, like overall height of the tree, minus depth plus 1, where h is the height of the tree. So we have to return the sum of the weight of all nodes in the tree. So the depth of node is the number of nodes on the path from root to that node, inclusive, with the root having depth. So like a root have depth 1. So the height of tree is the maximum depth among all nodes of the tree. So uh, let's take this example and try to uh, come up with the approach how we can solve this problem. So like we have given something like a parent and runoffs. So let's draw the tree, how the tree will look like this for this problem. So like this is the node 0, this is 1, this is node 2, this is 3, this is 4, and this is 5. So the parent of we can say the parent of node 0 is minus 1, so it will look something like this. And then the parent of node 1 is 0, parent of node 2 is 0, parent of node 3 is also 0, and the parent of 4 is 2, parent of 5 is also 2. So like our tree will look something like this. You can see like this is same tree as above. And now the every node has some value. Let's also write some value here. Like this is 5, this is 2, this is 3, this is 1, this is 4, and this is 6. And to calculate the like us we can say the calculate like the weight of the any node, the formula is nums of I into h minus d plus I. So its formula is nums of I into height, like overall height of the tree, minus depth plus 1. So like this is the formula to calculate the weight of any node. So let's see how we can find this thing. So you can see like to to get anything, firstly we need something like height. Like if we are standing at this node, we can't calculate the answer until we know the height of the tree. So for, like the first we can say the first sub problem for this to solve this problem is like we have to firstly find the height. So if you like don't know how to find the height, so let me explain it firstly how we can find the height of a tree. So let's say we have something, our tree looks something like this. So we have to find the height of the tree. So like we can simply run we can simply run a DFS, and initially we are at this node. So at this node the height is 1. So then we again like we can also like now as we are using DFS, we go to this node. Now here the depth become 2. Oh sorry, height become 2. Now we move to this node, the height become 3. We move to this node, the height become 4. So we can simply maintain a variable to store the like a maximum height we see, and then we can simply turn back here. and then do something like, again here is the value is going to be 4 again, like there is no left and right, so we go back, then we go to the right, like the here the depth height is 3, then no left and right, we move up, now we move to right, the height become 2, height become here, height become 3, and height become 4. So you can say the overall the height of this tree is 4. So let me firstly show you the how we can find the height. So we are simply using the DFS, and we are iterating we have something like we know like from 0 where we can what are the child of the 0. So we are simply iterating to all the child of any node, and depth become like 1 plus the DFS of that. So like we are simply doing the same thing, but in this we are instead of maintaining a variable, we are simply returning that value. So after that we are taking the maximum, because there may be possibility, let's say there is a 5 node, or like a more node. So in this, like from this height we get something like a 4, from this we get 5. So now we have to take the maximum of this both height. So so the height become the maximum, and then we can simply return answer. So yeah, so this is a simple way to find the height of the tree. So now our height, like we have already found find the height of the tree. So now the problem become very simple. So now as we already know the height, so we can simply traverse all the node, and then simply calculate the calculate this thing, and simply maintain a global we can say answer variable. Initially it's going to be 0, and then we can simply start a DFS. So sorry, like we can simply use a BFS. So if you know about level order search, we can say level order BFS. So in this what happen, firstly we are at this level. Initially we are going to take a queue, like a queue, and a queue has something like only one value, like a 0. So now the value is 0, and we also maintain something like a depth, so we can know the depth of the tree. So initially depth is going to be a 1, so we can traverse like all the children of that. So now let's take a queue only, like now initially the queue has 0 and 0, so we pop 0 from the queue and calculate the answer for the 0, like now our depth is 1 and the nums of I value is 5. So it becomes something like 5 into, what is the height? Height is 1 2, you can see like 1 2 3 in this case. 3 minus, like what is the depth? Depth is 1 plus 1. So we get something like 3 5 into 3 15. So is the formula is correct? Yeah, nums of I multiply by, yeah, the formula correct. So like we get 15 from this. So from 0, now we can move to 1 2 and 3. So we can simply add these values like 1 2 and 3. So now there is no, like we can say, children of the node 0. So now we move to next we can say next iteration. So now the our depth become 2, so we increase our depth by depth become 2. So now again this is already popped out, now we pop 1, and again calculate, use the same formula, like the value for what is the value for 1? Value for 1 is 2, so it become 2 into 3 minus 2 plus 1, because the depth is 2 in this case. So it give us a total of we can say 4, 2 into 2 into 2 4. So again we simply now like we have calculated the answer for this, we add left and the right, so there is no left and right, so we add nothing to our queue. So now we simply pop the next from the queue over. So queue has now two value, so we pop calculate the answer for the two, value is 3. So the formula become 3 multiply by 3 minus 2 plus 1. So in this case we get 6 as a answer. So again, yeah, like this, pop this out and add its left hand, we can say like all the children. The children are 4 and 5. So we can add something like 4 and 5 in this. So now the we can say next node is a 3. So let's pop out 3 and the calculate answer for 3. For 3 the value is 1. 1 multiplied by 3 minus 2 plus 1. So it become 2 only. So yeah, so now answer for 2 is already done. So add its left like all the children. So like there are no children, so we will add nothing. So now let's pop out 4. So we now pop out 4. For 4 we are going to calculate our answer, like the value is 4 in it. So it becomes 4 multiplied by 3 minus 3. So because we move we our queue become empty like for this thing. Now we move to our next iteration. So our queue has so our depth will also increase by 1, so it become 3. So 3 minus 3 plus 1. So this will become 4. So like there is no left and the right child, simply pop this out and similarly pop out the 5 value. And for this the nums of I value 6. So answer is going to be a 6 multiplied by 3 minus 3 plus 1. So which is going to be a 6 only. So yeah, so in this way we can simply calculate our answer. So the overall answer is 6 plus 4 10 plus 2 12 plus 6 18 plus 4 22 plus 15 37. So yeah, let's see. So you can see like the answer is 37 for this. So so this is a simple, like firstly we have to find the, we can say, overall height of the tree, and then we have to simply do the DFS, we can say BFS. So let's see the code for this. So firstly we are given a parent array from which we are creating the adjacency list of adjacency list, and then we are calling the DFS function which will give us the height of the tree. So now we are adding the 0 to our queue, and initially our depth is 0, and we are doing this loop until our queue become empty. And then I am taking the size of the queue and increasing the depth, because in this case depth, initially depth is 0. That's why I am increasing before performing any operation. So like you can see like why I am taking size here, not simply doing the complete until our queue become empty, because like for this the node in the this we can say the in this row has the depth of 1, in this has the depth of 2, and this has depth of 3. So for this, so initially that's why I am taking the size. The number the node which are present in our queue will all belong to the same depth. So I am simply popping out the front element from the queue, and then popping this out. And now our t value is simply the I am taking the node value for that as a t variable, storing in a t variable, because answer can be in a long, so that's why I am converting this to a long. So then answer is going to be a t into height minus depth plus 1. The formula is provided here. Yeah, same formula. So then I am adding into the answer, and then simply doing the adding all the child, we can say the child node to our queue, and at last simply returning the answer. So you can simply dry run this problem to get the better understanding for this. And this is a pretty easy, we can say not that much easy, but is a there are a lot of problems on this concept, this same concept. So now let's move to the third problem. Yeah, third problem is an interesting one. So the statement is pretty easy for this problem. So we have given a 2D matrix of m cross n size, and a cell can we have only two values, 1 or 0. 1 mean this cell is usable, and usable, and 0 mean we can't use that cell. And our task is to find two submatrix that satisfy the following condition. What submatrix must be a square of a same length, and the two submatrix may not share any cell, and each submatrix only covers cell where the matrix of a row comma column is 1. So we have to return the maximum possible area of each of the two square. If it is not possible to choose two square, then return 0. So the the problem statement is pretty clear in this. So let me zoom this out. So let's say we have given something like this matrix of n cross m size, and now we have to find the two square of the same size. So one let's say like these are the square first square of the size 2 cross 2, and we have to find some another like this yeah, this is the square. So we have to find two square, like a square is only valid if it all the cell in that square has a one value, and they are they must not be overlapped. It's like you can see like in this box we can say sub matrix or not overlapped, like this matrix is also valid 2 cross 2, but in this like you can see like this is overlapped. So this one this mat sub matrix and this sub matrix can also be a valid answer, but we don't have to return any like a starting and end point of the cell. We have to simply return the size of the, we can say, the matrix. So in this case, the size is 4. You can see like 1, 2, 3, 4. Some matrix has 4 cell. So the first problem is uh, how we can calculate like to check if a matrix is some matrix is a square or not. So the lead code also has a similar problem like this. We have to find let me guess what is the name. Uh, Maximum square matrix, something like this. uh yeah, so like in this problem we have to find the largest square that contain only one and return its area. So like if you have already solved this problem, you this problem is already this become we can say little bit easy, because now we know how we can efficiently find the square matrix of square matrix, all these square matrix. So let's see. So before so first like the first we can say the uh, we can break this problem into multiple smaller problems so that we can combine them to solve the whole problem. So first problem is we have to find the square we can say the long we can say all the sub matrix which are square. So yeah, so let's see how we can find. So let's assume we have already find the which matrix which submatrix or the square. So now how now the problem become problem will convert into how we can check these two matrix or we can say valid or not, because there may be chance there may be overlapping. So let's say in this case like this there is a 3 cross 3 submatrix, but there is only one. So we in this case this is not going to our answer, but in case of 2 cross 2 we have our answer. So let's see the constraint of the problem. So constraint of problem are pretty low, 500 only. So so the size of matrix is 500 cross 500, and m can be up to 500 and 500. So our size becomes something like this. We can assume something like 10 raised to power 5. So we can't do something like a uh, and square approach, because like if we do iterate some matrix inside some matrix, it become 10 raised to power 10 and even more than that, because this is greater than 10 raised to 5. So this will not pass. So let's see how we can efficiently find like two sub matrix are overlapped or not. So for this let I also haven't seen like ideas similar to this. So it also take me some time to come up with this idea how we can check this thing. 20, 21, 22, 23, 24, and let me draw the like index value also. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. What I am doing, like this will become the row become 2. So it will like it will 2 0 2 1 2 2 2 3 2 4 3 0 3 1 3 2 3 3 and 3 4 4 0 4 1 4 2 4 3 4 5. So let's assume our our first subarray and set is something like a 1 2, this is 1 2, and our second submatrix and that's something like 3 comma 3, this 3 comma 3, and our like matrix size k is like something like 2. So how we can check like we have given the end of the matrix like a square matrix of the both the matrix which we are comparing, and now we have to check like whether they are overlapped or not. So firstly I come up with I think a lot about how we can check this efficiently, because in case of 2 cross 2 we can't simply check we have to check we can simply check, but the problem is that we have multiple like because there can be multiple 2 cross 2, and there may be possibility like in the middle, let's say how many let's say we get 1000 2 cross 2 no, we will not get 1000, but let's assume. So if we have to iterate like all this will become like a n square, because in overall we get more than that much of the square matrix, because only 1 cross 1 is square, then 2 cross 2, then 3 cross 3, 4 cross 4, up to we can say 500 cross 500. So so it's not possible to check for the every like to compare every 2 cross 2 matrix some matrix or 3 cross 3 or something like that. So like so firstly how we can check like matrix or overlapped or not if we know it's their end values. So like the first value is 1 comma 2 and the second value is 3 comma 3. So like if the like this is x and this is y, so like if the x of the second we can say second subarray, or the y of the second subarray is greater than x plus that k, like the size of subarray, or y plus k, like if the both of like any of this condition is true, it means that they are not overlapping. So in this case we have something like x as 1 and y as 2, and this second sub matrix we have x as 3 and y as 3 also. So you can see like if we add like the sub like size is 2, so if we add 1 plus 2 it become 3. So you can see like it is less than or equal to this. So it means that they are not of sorry, yeah, it's a great like this value is x is greater than or equal to 3. So it means that they are not overlapping. So you can take an example, like if this condition is followed, they both are not overlap. So let's take sub matrix and that this 2 comma 1. So if we have something like 1 comma 2 and 2 comma 1, so like in this case x must be greater than equal to 3 and y must be greater than equal to 4. So like you can see like both condition are failed. So now the main thing is like, again we can't compare the two value at like the same time. If we have to compare like both these value at the same time, then again we have to iterate all the, like check for all the submatrix, because like to compare the 2 cross 2, because we have to compare for all the matrix, like starting from the 500 size, like if two not 500, because if there is a one 500 size subarray, then other is also 500, then they must be overlapped. So let's say assume we are starting from 500 for now for simplicity. So like, so the main idea in this, like they can independently, if the independent condition is also true, then this condition is also true. So you can take any example. Let's say this is 1 3. So if any of this x or y is true, it means that like the subarray is not overlapped. So that is the main idea. So what we can do, so we already know how we can find the square submatrix. Then we can simply check like whether we can whether this condition is true, like there is a two submatrix, if that we can say either the x or y is greater than that, it means that the condition is true. So the now the problems come like how we can efficiently find the to check like whether the find the we can say square matrix. So let's say we have 4 cross 4. So let's say how we can check. So like so there is a simple trick to calculate this thing. So like so initially we start with the like a 0 comma 0. We can say the top left cell, and if the value is if the value is 1, we can add 1. Like similarly for like if the I is 0 or j is 0, we can simply add 1 if it's 1. But in other, like this is also become 1, this 1, this become 1. So now for the other case, the value for this is the minimum of both this, like all these three, like minimum of this value, like we can say the left value, the up value, and the diagonally up value, like this diagonal value. So in this case the value, like minimum value of in both this case is 3. So the answer will become 2. So it mean by answer, the in this like in this matrix the value at an index mean uh, the like a square matrix of that size is ending at this position. Like by 2 we mean that the square mat, you can see like there is a square matrix which is ending at this position of size 2. So like this mean this. So like this value mean that. So now so let's calculate for this value. So for this value you can see like the minimum is minimum of both this thing is 0, and 0 plus 1 is 1. Similarly for this is going to also, like you can see diagonal values 0, it become 1. So again now for this like you can take the minimum which is 1 plus add 1, it will become 2. Similarly for this it will become we can say 2. For this also it become 2. Similarly for this it will become 2. But you can see like for this, like all the values are 2, but this value is 0, so it will remain 0. So for this like 0 plus 1, like this is 1. So like now we get all the like we can say sub matrix of size like that size. So like now our dp of I comma j represent the size of that we can say the subarray. So what we can do, we can simply maintain a 2D array. or we can say simply like we can say yeah, 2D array. And now we can add like for the value of 1, what are the subarray positions, like what is their x and y position. Like for this, x and y positions are 0 comma 0. So we can simply add like in x array add like 0, and y array add 0. Like for the other, what are the other like for this the value becomes 0 comma 1. So in x we add 0, in y we add 1. Similarly for this, like this is 0, so we don't include it in our answer. Like this value is also 1, so we add something like 0 comma 3 in our answer. Like x is 0, y is 3. So simply we can add this, and then we can simply so instead of taking it as array, we can take it as a set, so that it becomes sorted. And then we can simply check if if either x value if the either in a y case or in a x case, the last value of the set minus the first value is greater than equal to this k value for which we are checking. Like k is like sub array size, square sub array size. So if it is greater than or equal to that, it means that it is a true. We find two non-overlapping sub array, and we can simply return. So yeah, let's see the code for this. From code you get the better understanding. So this is the DP we are taking as a n cross m size, and now we are simply iterating. And if the v of I comma 0 is 0, it means that DP of I comma j is also 0. And if either I or j is 0, it means that it become 1, because if it is 0, it will already handle by this case. And then in else we can check like DP of I comma j is going to be 1 plus the minimum of we can say the left value, the up value, and the diagonal value. So from this we get our the we can say the square matrix subarray. Like what is the size of the submatrix. So initially our answer is 0, and because the n is like a 500, I am declaring n as a 500, and declaring x as, like you can assume it is a 2D array. Instead of declaring a 2D array, I am declaring it as a, we can say, adjacency list, which we simply we also use in a graph also. So for the that DP of I comma j value, I am adding it x value in case, like I value in case of x, and a j value in case of y. And then I am taking two set, and now I am iterating it from the left side. So why I am we can say right side, because taking the maximum value. So if we have something like this some, we can say, 200 cross 200 sub matrix 1, and we here get something like 10 cross 10 square sub matrix. So if 10 cross 10 and 200 cross 200 are not overlapped, it means like there must be a 10 cross 10 also. So but if we take the reverse of this, if we are taking firstly the starting from the smaller and then compare the larger value, then there we may get, like you can see, we get we can say square sub matrix which has not overlapped, but you can see like their values are different, because for this the value is 10, for this the value is 200. So in that case we don't know how, which value we have find. So that's why we are taking from the maximum, because if we get some answer for the minimum, it is always going to be a valid. So I am adding it into iterating that x and adding it into a, and then y in iterating the y array and adding it into a b. And then I am checking if the set size is greater than 0, I am taking the first value of the set and the last value of the set, and then comparing. If the end minus start is greater than or equal to k, I am simply returning the k cross k, because I am not storing the size of that square matrix. I am square sub matrix, I am simply storing the size, so simply returning that. Similarly in case of the b, if the same condition is true, then I am returning the answer. So yeah, so that's it for this problem. So I hope you enjoy the video. So if you enjoy this video, please like this video and subscribe my channel. Thanks for watching this video.